Hello everyone, welcome to Mikebaba-CATIA channel. Today we're diving into the most critical reference tool in the part design environment, the plane command. If you're ready to create complex, angled, and professional 3D models, then don't miss this lesson. Let's get started.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new.
Hello everyone. In this session, we'll continue reviewing the tools in the Reference Elements toolbar. The last tool in this toolbar is called Plane. We can use this tool to create a flat surface. Before we begin, it's important to remind you of a crucial point. As you know, we create our sketches on a plane. Up to this point, you've learned to use the main planes and the flat faces of the parts. But very often, it becomes necessary to create a plane at a specific angle and under special conditions. We use these new planes as a surface for creating a sketch. So, the skill of creating planes at various angles and in different positions in a space is important. The software provides 12 different methods to generate a plane. Part 1. Offset from plane. Assume we have a part with a volume like this on the screen. I click on the Plane command. The Plane definition window opens. In the Plane Type section, we can select the various methods for creating a plane. I click on the V symbol next to it. A drop-down menu appears. You can see that the software displays 12 different methods. The first method for drawing a plane is called Offset from Plane. When this method is active, the settings window also shows two other input boxes. In the top box, which is reference, we must define a flat surface. In the bottom box, which is offset, we specify the distance from the reference. Right now, the box next to the reference is blue and active. I click on the top surface of my part. The color of the surface turned orange. An orange arrow also appeared on it. The direction of the arrow indicates the direction in which the plane will be created. The word reference is written in red on the surface. Note the offset value. By default, it is 20 millimeters. In the image, a green plane with two arrows on it is also displayed. I can move the mouse pointer over these arrows. The mouse pointer changes into a hand icon. I click and hold the button. By moving the mouse, you can see that the position of the plane changes. The number inside the offset input box in the settings window also changes. The only thing that does not change is the parallelism of the plane with the top surface of my part. I click OK. A plane has been created. Now I change the view angle on the page to side view. You can see the volume and the plane created. With the measure tool, I specify the distance from the plane to the top surface of the volume. I double-click on the pad in the design tree. I increase the amount of the pad. You can see that the plane created rose as much as the height of my pad increased, so that the distance of the plane from the top surface of the pad remained constant. Now I right-click on the name of the plane in the design tree. From the pop-up menu, I select the Isolate command. I double-click on the pad in the design tree again. I increase its height value. You can see that the distance between the pad and the top surface of my volume has decreased. This is because by isolating the plane, we remove its offset dependency on the top level of our volume. In this case, the plane is no longer dependent on the volume. So, with this method, we can create a plane that is parallel to another plane or another flat surface. Part 2 Parallel Through Point. I activate the plane command again. In the framework, next to plane type, I activate the Parallel Through Point mode. Two options appear in the plane definition window. The first option is called Reference. Here I must first define a plane to the software. Right now the input box next to it is blue and ready for a plane to be defined. I click on one of the flat faces of my part. The second option becomes active. In this option, I must define a point. The defined point will lie on the plane that is being created. I click on a point that is created earlier. Immediately a green plane appears. You can see that the point is located on the plane. I set my view to a good position. The plane is parallel to the selected surface. You can see the parallelism of the plane with the surface. The software has highlighted the reference point and surface in red. I click OK. The plane is drawn. Part 3. Angle normal to plane. I click on the plane command again. The next mode is called Angle Normal to Plane. I activate it. The settings window changes to match the selected mode. Now we have 3 options that we must specify for the software. The first option is rotation axis. We must define an axis or a line to the software. The amount of rotation for the plane that is drawn is measured relative to that axis. I select one of the edges of my part. The software highlights it in red. Now the plane is created will be drawn rotated by the angle we specify relative to the reference surface. I will explain this further. But first, let's define the other 2 options for the software. The reference option is now active. I must define a correct surface to the software. For example, if I select this surface, I will encounter an error. In this error, the software says that it can't find a solution with this surface. I click on the reference framework to make it blue. Note that the top surface could also have been an appropriate surface. I return to the previous state. I select an appropriate surface. You can now see the preview of the plane in green. The plane is currently coincident with the selected surface. The reason for this is that the angle value in the option is 0. Now I double-click inside its box. I type the number 45. I press the preview button. You can see that the green plane has rotated 45 degrees relative to the selected surface. Now you understand the rotation axis. The rotation of the green plane happened around the rotation axis. The normal to plane button also makes the rotation angle 90 degrees. I click OK. The plane is formed. Part 4 through 3 points. I activate the plane command again. The next mode is through 3 points. With this mode, you see 3 options in the settings window. all three options are point options. Note that we can also select the corners of a 3D part. I select an existing point and two corners of the part. You immediately see a green plane. I click OK. The plane is drawn. Part 5 through two lines. I activate the plane command again. The fifth mode is called through two lines. In the settings window, you must define two lines to the software. First, I start with the simplest condition. I click on two edges of the part. You can see that their names are recorded in the line 1 and line 2 options. The plane is also displayed in green. I click OK. The plane is created. I repeat this for one edge and my line that intersect each other. You see the result. Now I activate the plane command again. I will set the drawing mode to through two lines. In its settings window, you will see an option at the bottom. This option is called 4-bit non-coplanar lines. This option is currently disabled. I have a line on the page that is inconsistent with the edge of my object. In the line 1 and line 2 sections, I select the line and the edge. You can see that despite their inconsistency, the plane was drawn. In this case, the software tries to draw a plane using the averaging method. The distance between the plane and each line is the minimum possible. I will press the cancel key. I will activate the command again. I will set the drawing mode of the page to through two lines. Now first I will activate the 4-bit non-coplanar lines option. By activating this option, I tell the software that the rules for drawing the page should be based on Euclidean geometry. I will select the line and the edge again. I am encountering an error. Part 6. Remaining methods. An important note. I click on the plane command again. The sixth mode is called through point and line. In this case, we must define one point and one line to the software. The seventh mode is called True Planar Curve. In this mode, I must define a planar curve to the software. In this case, the settings window has only one option called Curve. Look, I first select a curved edge of the 3D shape. Pay attention to selecting only the curved edge. You see that the plane is displayed and nothing has changed in the settings window. Now I click inside the curve box to make it blue. I select a straight plane of the volume instead of the curved edge. Look, the plane drawing mode changed to another mode. The setting parameters also changed. If I select a point, the software changes the settings window in keeping with it. I click Cancel. I activate the plane command again. I set the plane drawing mode to True Planar Curve. Now in the box next to Curve, I click on the curved surface. Again, you see that the plane drawing method changed. This means that the True Planar Curve method is only executed by selecting a single planar curve. Well, I will finish today's lesson here. I will cover the rest of the plane drawing methods in the next session. Please watch the lesson twice. Practice with me during the second time. Good luck, goodbye until the next lesson.
Let's build the future. Come with me, don't hold